Hello everyone, welcome to this KANPUR-NPTEL online course on space environments and its effects on orbital spacecrafts. So, in the last session we discussed about the satellite segment, that is the space segment. So, we started with the space segment and we discussed the mechanical mainframe, and mechanical mainframe we discussed the CFRP material, how CFRP material is very useful and it fulfills all the space requirements. Then we discussed the thermal control system. So, both the passive and active systems for maintaining the desired temperature range of the various subsystems of the spacecraft. Today in this session I am going to discuss, I will continue with the satellite segments, and this we will consider the space segments and the mechanical mainframe, one very important subsystem, that is the satellite mechanism. We will discuss that one, and then the onboard propulsion system, that is also very important subsystems of a spacecraft. Then we will go to the next topic, that is the electrical mainframe, and today we will cover the power system. So, mechanism. Let us try to understand what is mechanism, why we need it in a spacecraft. So, in a spacecraft there are various types of deployable components are used. So, this can be big antennas, that can be the solar panels. So, you can see in this picture itself, this if you see this, these are the solar cells. So, this is only 2 panels are shown. Suppose if you put the 3 panels and one panel size is something like 2 meter by 3 meter, then you will have the lengthwise 4 meter by 6 meter. If you have the 3, then 6 meter by 9 meter. So, these are the sizes, and antenna size also can be very big size antennas. It can be some 2 meter, 3 meter antennas are used generally in the spacecraft. And what is needed? A satellite is launched by the launcher. So, launcher basically in the launch vehicle, the satellite is put into this part is called the payload flare, satellite payload flare. So, in this, so whatever my satellite, whatever can be the satellite subsystems, but the satellite has to come, that I should be able to put it inside this payload flare of the launch vehicle. So, you can see, so this one when it was tested in the when the deployment testing was done of the solar cell, but when it was put inside the satellite, this solar panel, they are folded, and similarly and you see this one is shown, it is in between this, this is called the heat shield of the launch vehicle. So, you see this one, the same one, when you fold it, it looks like that. So, it becomes compact. So, the compact one you can put inside the satellite, and whenever the satellite comes out of the heat shield after when it reaches its desired orbit. So, in that case all those whatever the folded subsystems, they are deployed. So, for this, whether it is folding or unfolding, what is needed? The mechanisms, satellite mechanisms are needed. So, this is the reason the mechanisms is very important. These are the designed and employed, and also when it reaches to the orbit, there are a few of the components like the antennas, there can be the requirement of the scanning. So, there are the other components also which needs the some movements. So, those movements in these spacecrafts are done using the mechanism. So, we will show here, it is called the deployable mesh antenna. So, we will show you, suppose let us consider it is a 6 meter antenna. So, the 6 meter antenna, it is put in a like this all the mesh, it is put across the primary arm. So, across the primary arm, so this is it is folded like an umbrella. So, after that what happens, when it reaches to the orbit, so the deployment gets started. So, you see this is a partially deployed configuration, and what is fully deployed, that is called the unfurlable antenna. UFA means unfurlable antenna. So, I will write it unfurlable. And these are the different the trusses are used as a support structure, and this is the cable net. So, this will be the reflector, this will work as a, the other side it will work like a as a reflector antenna. So, this shows it is a deployment test. So, you can see that is how it looks, the antenna. So, this can be very big antenna, it is a 6-meter antenna. So, diameter of the reflector is a 6-meter reflector antenna. Okay. So, as I already told, this spacecraft it commonly contain onboard devices whose functions are based on mechanical movement to either modify the part of the spacecraft's geometry or to ensure some operational function of a component or an instrument. As I said, like in camera, the camera may be needed to do the scanning, or can be a radar where you need that antenna should be a rotating antenna. So, what are the movements? It can be slide, it can be roll, then it can be rotation, or it can be a separation, like injecting a satellite to the orbit where the separation is needed. Even the separations are, of course, the separations are needed in the different stages of the the launch vehicle. So, there also the mechanisms parts are used, but we are discussing the mechanisms which are used on board the spacecraft. Then unfolding, like we have shown, there is the unfolding of the solar panels, and then there may be the requirement of the spin, like there are various like momentum wheels, and all those things are used there, where the a wheel rotates. Okay. So, these are different mechanisms, or different types of movements are used in the satellite. So, you can see this is an unfolding of the solar cells. So, so this will be just before the deployment. So, it has reached the orbit, and once it reaches the orbit, so this type of the solar panel deployment starts. So, all this, the devices using this type of movements are carried out, these are known as the mechanisms. And when the spacecraft becomes more and more sophisticated, and when you are using various miniaturization of electronics and systems, so there that reliance of mechanism greatly increases. So, this all the mechanism, that is the process mechanism, should be very much reliable, otherwise there can be, it can cause a mission failure. Suppose this deployment of the antenna or the deployment of the solar panels does not happen. So, this will lead to the failure of the satellite. Okay. So, we will not discuss, it is a very broad topic, we will discuss a few only the important phases. So, first phase is the separation. When a spacecraft is separated or it is injected into the designated orbit, the mechanisms are used for injecting the separate. Then once when it started at the beginning of the mission life, you have to deploy the first one, the deployment is done in the solar arrays. Okay. Then the booms, then it can be antennas, there can be some of the instruments like you can use a radar or any types of, or maybe it can be a telescope. So, all these things they need to be deployed. Then whenever the end of the mission, there is mission is ending, and in that time also I need to tell about the next phase is the mission maintenance. So, once the beginning of the mission life means when you deploy all the instruments, then you have to maintain it. So, mission maintenance means there are various types of instruments are used, that is called the sun tracking, then there are various pointing antennas, that those antennas that point to the ground stations, and there are those antennas and instruments. Then there can be some active doors or the shields for the thermal management, then gyroscopes and the reaction wheels, these are for the attitude and the orbit control systems, as well as the thrusters. At the end of the life, when the satellite life is over, when the it is especially the end of the life of a satellite comes when the fuel gets exhausted, there is no fuel to operate the thrusters, and that time we cannot control the satellite. So, that is called the end of the life of the satellite. So, in that time we need to do some deorbiting methods. So, these things is also done by the onboard mechanism subsystem. So, why the deorbiting is done? So that the satellite you can bring it to the lower altitude, where by the the atmospheric drag and the atmospheric friction, the satellites will burn out. So, that it cannot contribute to the debris or the pollution of the orbits. Okay. Now, another subsystem which is very important for this spacecraft is the onboard propulsion system. Generally, these satellites are not put directly to the desert orbit. So, like in the last session, last session, I discussed a transfer orbit, this is GTO, geostationary transfer orbit. So, in that case, what is done actually, the satellite is put in a elliptical orbit, where the apogee is something like 200 kilometers, and the perigee is around 200 kilometer, and the apogee point it is something like 36,000 kilometer. So, after that, by using the maneuvering at the onboard thrusters, the orbit of the satellite is made a circular orbit, geostationary circular orbit. Okay. So, for that we need the thruster, means a propulsion system. It can be a chemical or electrical system. So, also when it is there in the orbit, sometimes because of the orbital perturbations, the satellite can get deorbited. So, in that case, if you want the orbit raising, okay, or you want to do some correction of the attitude, there is the orientation of the satellite. So, all these things are done by the propulsion system. So, many satellites are using the chemical propulsion, where which can give you a high thrust and simple design. Of course, this shows in a cartoon of the how the onboard the propulsion is used to accomplish various functions, like as I said, the maneuvering of the satellites, or attitude control or orbit control. There are also electrical propulsion system, onboard electrical propulsion systems are also coming up, and those gives you much reliable and the higher lives. Okay. So, there can be two types, one is the ion or the plasma the propulsion system, plasma thruster. It can be electrothermal, or it can be even electromagnetic or nuclear. So, we will not discuss each type, but these are the different types of the onboard thruster systems used. Okay. So, these were all the the subsystems of a mechanical mainframe, namely we discussed the structure, then the thermal control system, then the mechanism, and the last we discussed the propulsion, onboard propulsion system. Now, we will switch over to the electrical, that is the mainframe. So, basically this is the the electrical mainframe, So, the first subsystem under this category is the power system. So, power system is generated because whatever the satellite subsystems, whether it is a communication system or a attitude and orbit control system. So, each and every subsystem they needs the power. So, a satellite power system, it has the function of generating the necessary power, and that it is capable of doing under different orbital and the operating condition of the spacecraft. Okay. And it is capable of doing the power conversion also. We will come to that, what is the power conversion, like DC to AC or DC to DC, all those type of conversion it is capable of doing. So, generally this satellite power systems, it is generated, the power is generated from the solar radiation in sunlight. Of course, there are the other methods are also available, but mostly the satellite power system is based on the sunlight, that is the solar radiation. Then this solar, of course, along with that thing, the batteries are used, which stores whatever the electrical energy is generated from the solar photon, and whenever there is no solar that is sunlight available, especially during the time of the eclipse, so that time those batteries are used for the satellite operation. So, this cartoon shows that is this satellite, and satellite is illuminated by the sunlight, and these are the solar panels. So, these solar panels, so this you get this power is, so electrical power is generated from the solar energy. So, this shows this solar different solar panels. So, we will just see how the solar panels are made, what are the its the element. So, basically this shows a block diagram of a satellite based power system. So, you are having the solar panels. So, this sunlight is fallen on this, or the solar photon is fallen on this solar panels, and then it generates the power. So, then whatever the energy generated, the electrical energy generated, it stores or it charges the battery. Okay. Then you are having a battery charger, and then the batteries, and then it has to have this power conditioning. Power conditioning means the regulator. Now, there will be different subsystems which will different the power rating, different voltage rating. So, that this unit it will be able to distribute based on the the subsystem requirement. Somewhere you can read there can be some system where the low voltage is needed, there can be some systems where the higher voltages are needed. So, in that case what is needed, you have to do the conversion, the DC to DC conversion. For the some of the subsystems AC power may be needed. So, there the DC to AC conversion. So, all these things are done by this block, that is called the power conditioning. So, now just let us see block diagram wise. So, a electric power system, that is the EPS. So, EPS it consists of the power source, and the power source is mainly the solar radiation. Solar radiation in the visible range. So, this is the power source, and in fact, this is the primary source. Solar radiation is the primary source. Then we are having the secondary source. Secondary source means the whatever the batteries are used, which are charged by the solar, that is this output of those solar power. Then there is having the power distribution, as we just discussed in the previous slide, and then there will be the power regulation and the control. So, let us discuss what is the type of the primary source. So, the primary source is the energy which converts the energy available in another form. So, this is for in our case it is the solar. So, electrical so solar energy is, or the solar radiation in the visible range, it is converted to the electrical energy. And the secondary source, it is the source of energy, such as the battery battery of that is the electrochemical accumulators, which is substituted for the primary energy source when this cannot fulfill its function. For example, in an eclipse period, even this type of the batteries are used when it will act as a primary source before the deployment of the solar cells. Whenever the solar cells are not deployed, just after the injection of the satellite into the orbit, the batteries act as the primary source, and they also acts as a primary source during the eclipse time. Okay. So, the primary power source, so this is the external source is only the solar radiation. So, the solar flux at a distance of 1 astronomical unit. So, this 1 astronomical unit means 150 million kilometers. So, this is the value, that is 1353 watt per meter square. Okay. So, you can consider sun to be a black body of at 6000 Kelvin, and the spectral radiation is maximum about 0.5 micrometers, and 90% of the power is radiated is concentrated between the wavelengths ranging from 0.3 to 2.5, actually this is 2.5 micrometer. So, what is the how the solar energy is converted into electrical energy. So, sunlight is composed of photons or particles of solar energy. These photons, it contains the varying amount of energy depending on what is the wavelength. So, a photovoltaic cell, that is commonly called a solar cell, this converts sunlight directly into electricity. Okay. So, we will see what is the photovoltaic effect. So, basically a solar cell is a semiconductor, this is basically p-n junction, this is basically a p-n junction device, and it is made of it is a junction of the two types of semiconductors, that is the p type and n type silicon. So, it is something like a diode. So, you can see in the normal diode case we can do the forward biasing and reverse biasing by applying an external source, but here or by battery, here this external source is the solar photons. So, you can see this is the p type silicon. So, this is the p type silicon layer, and this is the n type. So, this part is the n type, and this is the depletion region. this is the depletion layer. So, whenever two junctions, so there will be a depletion region because of the diffusion of the holes and electrons. So, this is this comes from the physics of the p-n junction. So, solar cells operate according to the principle of the voltaic effect. Voltaic effect means the appearance of a voltage at the connectors or the connections to a p-n junction subjected to a photon flux. This is also called the photovoltaic effect. So, photovoltaic effect means the appearance of a voltage at the connections to a p-n junction subjected to photonic flux. Now, the single cell has very low output power. So, in order to increase the power, so this photovoltaic cell they are put in a form of the arrays, and they and then when you put those in a form of a rectangular array, and then those arrays you can put in series as well as in parallel to get the desired power. So, you can put those in serial and parallel, that again. Okay. So, this series and parallel combination it comes from to maximize the power. So, that can be seen from the voltage and the IV characteristics. What is that point I need to have this voltage and current combination that I can operate it, so that the power output is maximum. So, as I was saying that a single array, its output power is very less. So, we need to put those cells in arrays, and that the parallel and series combination is done based on what is the output power we need. And the PV cells these are made almost entirely from the semiconductor silicon. So, that is generally processed into an extremely pure crystalline material which absorbs the photons from sunlight. And silicon cells are realized in a relatively thick monocrystalline chips of thickness, it can be 500 to 200 micrometer. Okay. And it so the thinner the lighter, so it can have 20 to 60 milligrams per centimeter square. Okay. So, in this session we discussed basically this. So, the first one we discussed is a so, if I summarize today's session, so we discussed the mechanism of this is the mechanism subsystem of a satellite. So, by using mechanism subsystem, what we are capable of doing. So, we are able to use the a larger subsystem which cannot be generally it cannot be accommodated in the launch vehicle. So, by using different folding mechanisms, we are capable of fold the subsystems like a solar cell or the antenna. Okay. And then the mechanism. So, this is one is the folding during launching. During launching, and the second operation is the movements of the system in the spacecraft. So, it can be this some instrument rotation like camera or antenna scanning. Antenna scanning. Of course, before then the deployment of after it reaches its designated orbit. Okay. Then the fourth operation I have seen, that is the that is the station keeping then attitude and orbit control, attitude and orbit control system. And the fourth and the last, that is the application of the or the use of the mechanism, we have seen that is the deorbiting, deorbiting at the end of life. Of course, then after that we discussed the that is. So, then after that the next we discuss the power system. So, we have seen in the power system that is the primary source, as the solar radiation, I use the that is the photovoltaic cell and the array of it. So, this is called the solar cell. Then we discussed what is the secondary source, as the batteries. Okay. Then the that is the distribution, regulation as well as the conversion. Okay, so let us end the session here. Thank you very much.